Welcome pre-cal students to class today on, what is today? Wednesday the 16th. Wednesday the 16th. Good to have you guys along. I know you are excited to be here. Humor intended. And let me get on the right page. I'm not even on the right page. Hopefully I'm on the right class today. Hope you're ready to learn. Hope you're ready to listen. Hope you're ready to work hard, as should always be the case. And let's take a look at some announcements here that should interest you. Especially number 2, man. Fall break is almost here. Woo. All right, you got a test this Monday. That's the last day of class for the first quarter. So this coming Monday, you're going to come take a test here or ask questions on your review sheet or do both, whatever you choose to do. And I really want to encourage you to be ready for your test because, yes, my voice just cracked, because you don't want to take that test home over fall break. Or maybe you do. I don't know. Maybe you're going to miss this class so much you'll want to work on your test over fall break. But this Monday, you're coming to my house. If you can't make it, please let me know no later than Sunday so I can plan for that. Fall break is almost here. So next Monday, or this coming Monday, however you want to say it, is our last day of class. And you will not have another video to watch then until Tuesday of the next week. That's when class will start again, okay? Stay on top of your integrity sheets. They've got to be done. Your integrity sheets, make sure you know where you're at. You're filling them out daily. Don't get behind in the videos. Don't. It's a domino effect, an avalanche. You don't want to do that. Contact me if you need help, okay? Well, men, I like to go fast. I've told you before, my philosophy is this. You can always rewind the video if I go too fast, but you can't speed it up if I'm going too slow. So I'm going to go fast, and all you got to do is pause the video, back it up, and if I'm going too fast, okay? We're going to look at a topic today called inverse of trig functions. Inverse of trig functions, lesson 6.4. Now the date today is the 16th. Let me write that down for you. The 16th, okay? So we're looking today at a topic called inverse trig functions. The lesson number is 6.4. Let me grab a quick drink of water. And the date today is the 16th. Now, we need to start off today by understanding what a certain notation means. I would write that down if I were you, okay? We need to start off today by understanding what a certain notation means. If you don't know what these notations right here mean, then you're not going to be able to solve the problems. So go ahead and take some notes on this and watch what these notations mean. By the way, here's how you would say this. You would say inverse sine of negative square root of 3 over 2. So the first word you say is inverse. Here you would say inverse, and the second word you say is whatever your trig function is, okay? So you would say inverse cosine of 1/2. Inverse secant of square root of 2. I just don't want you to go to college one day and look dumb and say, yeah, teacher, that sine to the negative 1. That's not how you say it. You say inverse sine of, and then whatever you have right here. All right, now with that in mind, let me show you what this notation means. All right, please take some really good notes on this. Whenever you see inverse sine, it just means this. It just means you're looking for an angle. We'll call it x, so that when you take the sine of that angle, you get that right there. That's all that this means. So when you see inverse sine, it just simply means you're looking for an angle, so that when you take the sine of that angle right there, you get negative square root of 3 over 2. Okay, so inverse cosine just simply means cosine of some angle. I'll call it y this time just because I feel like being different. So that's all that this means. It means you're looking for an angle so that when you take the cosine of that angle, you get out 1/2. That's all that it means, guys. So inverse secant just means you're looking for an angle. We'll call it z. You're looking for an angle so that when you take the secant of that angle, you get square root of 2. So do you get it okay? That's all this means when you see sine to the negative 1, cosine to the negative 1, secant to the negative 1, or the right way to say it, inverse sine, inverse cosine, inverse secant, inverse tangent, inverse cotangent, inverse cosecant. When you see any of that, any of those notations like this, it just means, hey, tell me what the angle is. It just means you're looking for an angle, nothing else, okay? In fact, by the way, the answer to this would be 60. And if you don't believe me, real quick, take your calculator and type in the cosine of 60, and you'll get out 1/2. So the answer to this problem right here would be 60 degrees. Or, if I ask for it in radians, pi over 3. Okay, that's all that notation means. Now, next, we need to understand, excuse me, that if we don't put a limit on our answers to these types of problems, we will have infinite answers. And you're like, whoa, dude, really? Yeah, let me show you what I mean. Let me explain. Okay, let me say this again. We need to understand that if we don't put a limit on our answers to these types of problems right here, these types, we're going to have infinite answers. Let me explain. Would you please take some really good notes on this? Write down inverse cosine of 1/2. Please write that down. Inverse cosine of 1/2. Now, get your calculators out. I want you to write down these four answers. So, Mr. Earhart, you're telling me that if I take remember what this inverse cosine means, guys. It means cosine of some angle gives me 1/2. Do you remember that? We just learned that a second ago. So here's what this means. So, Mr. Earhart, you're telling me if I take the cosine of 60, I'll get 1/2? Yep. You're telling me if I take the cosine of negative 60, I'll get 1/2? Yep. Are you telling me if I take the cosine of 420, I'll get 1/2? Yep. Are you telling me if I take the cosine of negative 420, I'll get 1/2? Yeah, you will. You'll get 1/2. In fact, if you don't believe me, get your calculator out and type in cosine 60, and you'll get 1/2. Type in cosine of negative 420. You'll get 1/2. In fact, if you want to, type in the cosine of 780, I believe it is. I hope that's right. I'll check mine real quick. Type in the cosine, let me calculate on cosine of 780, and you get 1/2. Okay, or 0.5, same thing. So I'm not going to go into great detail. I will say this. The reason is, remember how I taught you reference angles? You can go around once and again and again and again on your coordinate plane. Remember that? I hope you do. I'm not going to quiz you on why this is true, but I just did show you why. But just trust me, there are infinite amounts of answers for each of these if we don't put a boundary or a limit on our answers. So we have to put a limit on our answers for these types of problems. So take some good notes on this. I'm going to show you the limit for sine. I better put negative ones here, I guess. I'm going to show you the limit for inverse sine, inverse cosecant. I'm then going to show you the limit or the boundaries for cosecant, inverse cosecant, or cosine and secant, so on and so forth, okay? I'm going to show you the boundaries. Now, let's start off with sine here, okay, and cosecant. The boundary is first quadrant and fourth quadrant. Now, what that means is you want all of your answers to run here from 0 to 90 degrees and from 0 to negative 90 degrees. Okay, let me go over that again. You don't have to explain why, just memorize it. Anytime I give you an inverse sine or an inverse cosecant problem, all of your answers should be in either the first quadrant or the fourth quadrant, nowhere else. Okay, so what that means, we're going to say x. That means x has to range between, now watch this carefully, from negative 90 degrees. Remember, if I go down like this, it's negative 90, all the way up to positive 90. All right? So there you go. Now, if you didn't understand all this, you know what you can do? You can memorize it. Anyone can memorize this. In fact, let me go ahead and tell you right now, this one over here is the same. So go ahead and make note of that now. This one over here, the boundary for inverse tangent and inverse cotangent is identical. It's the exact same thing. So now you really only have two sets to memorize, because if you'll just remember that sine and cosecant, they're inverse functions of each other, and tangent and cotangent, if you'll remember they have the same boundaries, then I think you're going to be sitting pretty good, guys. Okay? All right. Now let's come over here, and I can get into explanation why. I'm always trying to keep your time limit down. I'm not going to get into why. I guess I will very quickly. Sine and cosecant are positive here and negative here. Tangent and cotangent are positive here and negative here. And then cosine, we're going to use cosine secant. Their boundary is going to be quadrant 1 and quadrant 2, and reason being is cosine's positive here and it's negative over here. Now if you don't understand why, don't worry about that, please. I'm just trying to show you the boundary. Now I think we're getting a little sloppy here, so I'm going to go ahead and draw some lines so we kind of keep things separate here. There we go. All right, now the boundary for inverse cosine inverse secant runs first to second quadrant, so it goes here all the way to here. So that just simply means your answer has to be greater than or equal 0 all the way to 180 degrees. Here we go. I mean, isn't that where this range runs from? It starts here at 0 and it goes all the way to 180. So there you go. So now you've got your boundaries, and you're going to have to memorize these, men, for the test this coming Monday. You're going to have to know this. Okay, it's just part of math, is learning stuff. Getting a drink of water, excuse me. So moving on, okay? Back this up and watch it again if you need to. All right. Now, I want to encourage you to write this down. Remember our special triangles, guys? Do you remember that? I'm going to go ahead and do something. I don't like having this on the same page. I'm going to change my notes. Well, I'm just going to let it go for now. Remember our special triangles? Well, what I did is I thought I'd be a blessing to you guys, and I thought I would take it and put it in a chart for you. So the sine of 30 is 1/2. The sine of 45 is square root of 2 over 2. The sine of 60 is square root of 3 over 2. Thanks, Mr. Earhart. You're welcome. So here's all of sine, cosine, tangent, cosecant, secant, cotangent of 30 degrees. Okay, they're all right here. And then sine, cosine, tangent, cosecant, secant, cotangent of 45 degrees. And then sine, cosine, tangent, cosecant, secant, cotangent of 60 degrees. So they're all right there for you, okay? So I would encourage you to write this down, pause the video, and write it somewhere in your notes so you have it handy. Now, am I going to let you have this sheet out when you're taking a test? Was that a joke? Just kidding. I'm joking. Of course not. No. On a test or quiz, you're still going to have to draw your triangles, put a 45 right here, put a 1, put a 1, put a square root of 2. You're going to have to put a 30 here, a 60 here, put a 2, a 1, and a square root of 3. But my point is this, at least for homework tonight, you can use this chart and it will really, really help you and make the homework go a lot faster, probably even faster than using a calculator, okay? So here's a chart, and we're going to use this chart a lot. Now I need you to take some really good notes. I need you to pay attention, and I need you to do your homework and watch the homework help video and make sure that you're understanding these problems and getting them right, okay? All right, moving on. Here's the first problem that we're going to do today. In fact, I'm going to go ahead and copy this so that I have it whenever I need. I'm going to go ahead and put it as a group. Here we go. And copy it. All right. I'd like you to copy this problem in your notes, please. We're going to solve inverse sine of square root of 2 over 2. Inverse sine of square root of 2 over 2. Now, the first thing you do is you remember, you say to yourself, wow, that is a really straight line. You say to yourself, okay, sine deals with quadrant 1 and quadrant 4. Everybody with me so far? We learned that right back here, okay? Sine, quadrant 1, quadrant 4. And then secondly, we say to ourselves, I'm going to rewrite this equation. So now I'm going to write sine of some angle equals square root of 2 over 2. Now, do you see this right here? Isn't it positive? Sure it is. So that means we're in the first quadrant over here. Because whenever you take the sine of an angle and get a positive answer, you wouldn't be in quadrant 4. That doesn't make any sense. You'd be in quadrant number 1. So, now if this would have been negative right here, negative square root of 2 over 2, then we know we'd be down here because sine is positive in this quadrant and sine is negative in this quadrant, okay? But it's not, it's positive. So we know we're in this quadrant here. And now look at the chart that I gave you. What angle, when you take the sine of an angle, when do you get out square root of 2? Well, here's sine. Go along your chart. You don't have to do sound effects if you don't want to. Boom, square root of 2 over 2. So the sine of 45 degrees is square root of 2 over 2. Sine of 45 degrees is square root of 2 over 2. Now let's make sure that falls in our boundary. The boundary for sine is x has to be greater than or equal to 90 and less than or equal negative 90 and 90. So yeah, we're totally fine. 45 falls in between negative 90 and 90. So the answer, based on my chart here, the sine of 45 degrees gives me pi square root of 2 over 2. So the answer would be 45 degrees. Now if I asked you to give it to me in radians, then you would put pi over 4. I think the homework tonight asks for both. Okay? Pretty cool. Pretty cool. All right, let's continue on. Sorry, my son is crossing the street. I'm making sure that he is looking both ways and doing what he's supposed to do. All right, moving on to the next problem. I hope this makes sense. Let's try another one. Copy this in your notes, would you please? Inverse cosine of -1/2. All right, first thing we do is we draw our boundaries. Okay, cosine, I remember, is quadrant 1 and quadrant 2. So my answer must fall between, my x must fall between 0 and 180 degrees. All right, next I rewrite my problem over here. Inverse cosine means cosine of some angle equals -1/2. Now hold it, hold it, hold it, hold it. Look, whenever I take the cosine of this angle I'm trying to find, I'm going to get out a negative answer. So that means I'm in this quadrant right here. I'm over here, guys. Do you see that? I know that because this is negative. If it was a +1/2, then I would know that I was in quadrant 1. Okay, because cosine is positive here and cosine is negative over here. All right, now let's go ahead and let's take a look at our chart. When I take the cosine of an angle, what angle gives me 1/2? Well, let's see, here's cosine, looking for 1/2. There it is right there, 60 degrees. The cosine of 60 degrees is 1/2. But hold it, that's not right because 60 is in the first quadrant. So remember what to do. Remember the bow tie triangle. Remember you always do your triangles on the x-axis like it's a bow tie. Okay. So here's your triangle right here, and what is that angle? 60 degrees. So put a 60 on the inside. So then what would the reference angle be? Remember, you always start on the x-axis and you go until you hit this right here, the hypotenuse. There you go. All right. Now, since 60 is my angle inside the triangle, my reference angle here, think about it, if I went all the way, it'd be 180, but I stopped 60 degrees short, so my answer is 120 degrees. Now, test it and see. If you'll take your calculator and type in the cosine of 120, you will get -0.5, which is what you want to get. So the answer is 120 degrees. And by the way, does that answer right there fall between 0 and 180? Sure it does. Let's try another one. Inverse tangent of -3/3. Hold on one second. My son is singing. Okay, I am back from the concert there. All right, let's see what's going on. All right, now tangent, first thing you do is you think your boundaries. Boundaries for tangent I taught you would be quadrants 1 and 4, because tangent is positive here and negative here. And so I can basically say then x has to be greater than or equal to -90, going all the way up to 90 degrees. So your answer has to fall between -90 and +90. Now, let's come over here and rewrite our problem. So tangent of x equals -√3/3. There we go. So we're looking for an angle that when I take the tangent of this angle, I get out -√3/3. Let's go ahead and paste my chart here. And let's go across with tangent here. √3/3. Here it is. Tangent of 30 is √3/3. Tangent of 30 is √3/3. So I know I'm looking at 30, but hold, that's not going to work, because when I take the tangent of 30, that gives me out a positive √3, and I want a negative √3. So I've got to come down to my negative quadrant here, draw my bow tie triangle like this. And by the way, don't use that phrase in college. That's just my own phrase I've made up, the bow tie triangle. So that's just a homemade phrase. And right here I put my 30 inside my triangle. Now, yes, students, you're used to going like this, aren't you? All the way around and saying, oh, the answer is 330 degrees. Hold it. Does 330 fall between -90 and +90? Not even close. So in this case here, we're going to go negative. We're going to rotate down and go the opposite way. And we're just going to say, well, that would be -30 degrees, right? I started here. I went down, I hit the hypotenuse. Clockwise means negative, so the answer is -30 degrees. By the way, if you don't believe that, go ahead and take your calculators and type in tangent of -30, and you'll get out this decimal right here. You'll get out negative 0.5773502.692. And guess what? This decimal right here is the exact same thing as this right here. Just trust me, it is. Now, I hope this is making sense, okay? So let's quickly review. I think the next problem is going to be a calculator problem. Yeah. All right. So let's quickly review these three problems. First of all, you always write out your boundary. Of course, you don't have to do all these steps. If you're getting it and you want to save time and skip some steps, that's totally fine. But I would write the boundary out first, like we do over here, and then rewrite your equation or your problem, excuse me, and then use your chart if you need to, and then go from there. Now, if you're saying to yourself, well, Mr. Earhart, not all of the angles in the entire world obviously fall on this chart. Of course, you'd be correct. Oh, by the way, I forgot something. I'm so sorry. Let's go back. You got to remember to write your angles in degrees also. So here your answer is 120. Do you remember how to convert? You got to write your answers in radians too. Remember how to convert 120 over to radians? 120 pi over 180. Excuse me, my son has a question. Hold on one second. Okay, so here we go. 60 would go into both of these numbers. 60 would go in 2 times and 3 times. So the answer would be 2 pi over 3. So 120 degrees or 2 pi over 3 would be the exact same thing. All right? You got to learn to do this, guys. So negative 30 would be negative pi over 6 radians. You've got to be able to write your answer both ways. Okay, moving on. Now, let's go ahead and grab our handy dandy calculators, and let's very quickly learn. Sorry guys, I'm having some child conversations here. Hold on one second. Okay, I am back again. Here we go. Now grab your handy dandy calculators, and it really doesn't matter if you're in degree or radian mode. We're going to do both. Let's do it all the same. Let's make sure you're in degree mode. Now, obviously, this is not going to be one of our problems. It's on a chart. So the first thing I have to do is I have to rewrite the problem. Cosine of some angle should give me 0.2689, right? And remember I taught you before, when you're looking for an angle, that's when you use your inverse or your second cosine button. So with your calculator, I would like you to type, and actually I guess I should go ahead and show you. So if you would please just give me 1 second here. It'll take just a second. Real quick here. Let's see what we got. All right. Thanks for your patience, guys. All right. There we go. And now we can use this from here on. Okay. Now, if you look at your calculator, if you have a grapher, I would hit the second button first, okay? Second button first, and then hit cosine. And when you do that, this is going to pop up on your screen, cosine -1 with the parentheses. And then type in 0.2689, and go ahead and hit enter. I'm doing that right now on mine, so second cosine 0.2689, and then hit enter, and you get 74.35 degrees. 74.35 degrees. Now let's do it in radians. So is everybody watching the screen here? So next, what you're going to want to hit is you're going to want to take your calculator and hit the mode button right here. I'm circling it. So push mode, and then you're going to scroll down, I think, to the third line, and you want to highlight the radians right there. So go over and highlight that, and then hit enter, and then hit second quit or second mode, so you come out of that, and now hit cosine. Now hit your second cosine, so it pops this cosine -1, and then type in 0.2689, and now this time when you do that, you're going to get out a different answer. You're going to get 1.2976. I'm just going to say 1.3. So 1.3, and that would be radians. So this answer here, you do not put a degree symbol like that. You do not. And this one you do. All right? Not too bad. Let's try another problem. All right. Since our calculators are still in the radian mode, let's just go ahead and solve this problem first using radians. So first of all, we understand what we're really doing is we're looking for an angle that when we take the sine of that angle, we get 0.20345. So with your calculator, go ahead and hit second and then sine, and when you do that, up pops sine with a -1 and a parentheses. Go ahead and type in 0.20345. You don't have to close the parentheses. You can if you want to. That's totally up to you. And I'm typing mine in now. I do not have these done ahead of time. 0.20345. And if I'm typing it in correctly, I'm getting this out for an answer. 0.204880339, but 0.20 would be fine. So 0.20 radians. And you don't have to write the word radians. If there's no degree symbol, then it's understood to be in radians. Now let's go to our degree mode real quick. So remember what to do. You hit mode, and then go down to the third line, and you'll see degrees right here. Go ahead and highlight degrees and hit enter, and then hit second quit and come out of this mode. So go ahead and highlight degrees, hit enter on it so it's highlighted, then come out, and then go ahead and type in the same thing. Go ahead and type in, hold on, I'm having some issues here with my calculator. There we go. All right, go ahead and type in, hit your second, and then your sine, and up will pop sine to the -1. And then go ahead and type the thing in, same thing in 0.20345. But now when you hit enter, you should get a different answer because you're in the degree mode. You should get 11.74 degrees. 11.7387785 degrees. Okay? All right, one more, and I think that we are done. Two more. All right. Well, you've done really well. I don't want to bore you to death. We might do one or two more. We'll see. I guess the main thing I was concerned about here is I wanted to point out to you that when you have cotangent, cosecant, or secant, it's not on your calculator, so you got to rewrite it. So first of all, let's come over here. Cotangent to the -1, of course, simply means that you're looking for an angle. We'll call it x. That gives you 1.265, okay? But since we don't have a cotangent button anywhere over here, then we're going to rewrite this. Instead of saying cotangent of an angle will give me this, I'm going to write the inverse of cotangent. So I'm going to put tangent. And you can do that by writing tangent. That's basically like flipping. That's like flipping cotangent. It really is. So if we flip this side, then we got to flip this side over here. So it would be 1 over 1.265. This expression here and this expression here are totally equivalent. They are the exact same thing. So I wrote my original problem like this, like we learned how to do earlier. Then I realized my calculator nowhere has a cotangent button, so I rewrote it like this, so now I can use my tangent button. So I flipped this side by writing the inverse of cotangent, and I flipped this side by flipping it. Okay, so that's what I did. Now I think we're still in degree mode, so I'm going to go ahead and find degrees first. So go ahead and hit second, tangent, and up will pop tangent to the -1 with the parentheses, then type in, hit 1, then hit divide, and that'll come up, and then hit 1.265, and then close your parentheses. So I'm going to go ahead and do that now. Second tangent, and then 1 divided by 1.265. Enter. I'm getting 38.32685832 degrees. So I'm going to go ahead and put 38.33 degrees. You can really round wherever you want to. That's up to you. Okay? Now, let's go ahead and do what we've done before. Let's find the answer in radians real quick. So let's go to hit mode, and then go down to the third line, and be sure and highlight radians right here, and hit enter on it. Be sure and hit enter so it's highlighted, and then hit second quit and get out of there. So I'm doing that now in my calculator, down to radians, hit enter, and then now type the exact same thing in. So hit tangent to the -1, type in 1 divided by 1.265, hit enter, and you're going to get this. And that's going to be a different answer because you're in radians now. You're going to get 0.6689. And did you notice in all these problems I didn't check what quadrant I'm in, all that kind of stuff? Reason being is your calculator, pretty cool, is already set up to do a lot of that for you, okay? So if you feel like you've got a really good grasp on this, then skip this next problem, fast forward the video, and go ahead and get started on your homework. You have 16 problems. That's a pretty normal high school amount of homework to have. If you want to watch another example, then watch this one, okay? Here we go. First of all, secant to the negative inverse secant, which simply means I'm looking for an angle that when I take the secant of that angle, I get negative 1.1677, right? Now, we realize, there's no secant on my calculator. So I'm going to flip secant by writing cosine, which is the inverse of secant. But if I flip one side, I've got to flip the other side. So it'd be negative 1 over 1.1677. I don't care if you put your negative in the top or the bottom, just don't put it in both, okay? It really doesn't matter. So I'm already in radians, so I'm going to go ahead and hit second cosine, and up pops cosine negative 1, and then type in negative 1, then hit divided by 1.1677. If you want your negative sign with this, then hit 1 divided by negative 1.1677. I don't care where you put the negative, top or bottom, you will get the same answer. It doesn't matter. So negative 1 divided by, I'm typing it in now, 1.677. I'm in radians, hit enter, and I'm getting this for my radians, 2.21 radians, okay? Now, go ahead, you know how to do it. Go back to your mode. I'm not going to show you again. Go back to your mode and change over to degrees. And then we're going to type in the same thing again, only now we're in degrees. And I'm changing mine right now to see what I get. And I'm getting out 126.6055703 degrees. Or, in other words, 126.61 degrees. Again, you can round wherever you want to. I hope you're getting this. I hope you're understanding. If you have any questions or any concerns, please call me or email me and get some help, okay? Here's your homework assignment. I want you to do page 575, numbers 1 through 31, the odds. It's 16 problems. Work hard. Please do your homework. And hopefully you're understanding this material.